Hello and welcome back. I'm sure you enjoyed that break with the stretch and got something to have a bite and had the energy flow coming back. So now let's get in and learn about the scheduling algorithm in the IDE. I already opened the IDE, so I'll minimize this. I'll go to the IDE and we'll start from there. So I'm going to copy from previous session and I'll start that. I don't want to confuse from the previous session, so I'm just copying this project, copy and come here and paste it. It will ask for a project name. We are on day 19, but also make sure you connect the hardware at the same time. So if you see, my hardware is connected, so make sure it's connected, otherwise you'll get error messages. So we are on day 19, task scheduler part 2, and I'll put as scheduling algorithm, so we know. Okay, so copy. It will start to copy and a new algorithm with the day 19 happens. Good. So we are on day 19. I'll close all of this so you don't get confused. I will start from day 19 main. So go to main.c, and this is what we learned from previous session. We have written the macros and the stack space created, the system clock. We did all of this tick timer and we initialized all of this, and we have written the main program. We also enable the processor false, and all the task handlers been created. Okay, so now first step in the scheduling algorithm is to first create the task control block. To do that, you need to go and declare a type def function. Enable processor sysdig handler. So okay, I'm going to write a function here that's type def struct and then type def struct. You need to start with the data type event underscore 32 t and the PSP value PSP underscore value. So this is for value. This is for multiple tasks, and then you need to declare the data types, multiple tasks. And next one, you need to declare the data type for the current state and the that's for the current state. So now you need to declare for the PSP value state. Now you have to declare for the current state, which is always 8-bit uint 8 underscore t, then the current state and then you finish saying which handler you need to ask it to go, the task handlers, task underscore handler of void. So this is a structure, type def structure, and then finish up with TCB, telling it's TCB finish, so TCB underscore t. So that finished that. Then right click and build the project, because we are on day 19, so we got to build that. Right click, build project. current state. What did we use here? Current stick current state uint underscore t error. Save, build project. Uint, that's uint 8 underscore t or attribute before state. So current, maybe the state uint t, uint 8 underscore current state. So I will run the program now to see if I can be error free. It's running the program. I'll get it. Yeah, that's error free. That's 0. That's 0 warnings, which is always good. Thank you. So then we need to go the next step. You need to run this and get the value. So you declare the control block. The next step is to get the values of the PSP value. To do that, the next program is, now you got to create the function. So you're going to write uint 32 underscore t, and then get underscore PSP value, PSP underscore lowercase value of void. So that's another function, but you got to declare this function up. Control C, you're coming up here where the declaration are. So come here and declare this to get the PSP value. Okay, so we'll go into PSP value and we will write the program. What does it need to return? It has to return with current value, with the user tasks, user underscore tasks of the current task with linking with the PSP value, PSP underscore value, and before doing this you need to declare the current task as a global variable. So just copy the current task. We'll declare this as a global variable. So come here, current task, and also you need to typecast to underscore t current task, saying that to be on the first task, current task running on the first task. So save now, right click and look for any errors. Right click, build the project. User task, the current underscore task dot PSP value, return user underscore tasks, user underscore tasks. So we have written user underscore task, but we haven't created the user task, so that's why the error is user task. Task is 1, the return user tasks PSP value user task TSP. Okay, we didn't declare under this. You need to define the TCB value, so sorry. So control block, after it's finished, you need to set that to max task with the user tasks. So here you got to declare and then link that with the number of tasks. Maximum, you copy this max tasks. Copy this, come here and include that here. And then semicolon. And save and run. This will eliminate the error. Build project. Yeah, it's happy. So once it got the value, now you got to save the value. So I'll just copy the same. Control C. Control V. So this is to save. First we got the value, now you have to save this value. How are you going to do it? Save the value. You need to start with again you got to declare this function above, so copy this and go here and then declare the function here, come here, back, and then write the function int 30. Oh yeah, we created the save value. So inside the save PSP value, we're going to pass the argument. So you need to pass this current data to get the value, the get value. So you got to change that to T and pass the current value of PSP underscore value. So copy this. You got to declare this in the function here instead of void. This is the argument you're passing. So you pass that. So come back and finish the function current value. So in this you link with the user tasks now. So user tasks of the current task with the PSP value. So you linking to this value dot PSP underscore lowercase value will be your current PSP value. Current, copy this. Yeah, current. Control C, come here. Value. Okay, so that's done. So now save and do a run to see if we have any errors at this point. Right click, build the project. Sorry, I'm getting a bit thirsty. I'm just going to have a sip of a drink. Sorry. Thank you. Two errors. Undeclared current task is undeclared current task. So what did we return here? Current task is lowercase, sorry, current state. So lowercase c current task will be okay. So save and then run. Now build project. This will pass the stage. There is a warning. Warnings are okay as long as you see the error free. Yeah, that's good. Because warning may be related to some other thing that's linked. So you need to write and finish to get rid of all the warnings. So now we return the save function. The next one is to build the state task, update the task. So you got to write a function for that. So void update next task of void. Again, you need to declare this function out here. So come here and declare this. Now what's inside the update task next? You start off with updating the current task, increment it first by saying increment. So you need to increment maximum tasks now to 5 maximum tasks. So you got to change the value here to 5. Okay. Maximum task. So the next step is you got to modulo that current task with the manual task. So the round robin, once it finishes the 4 tasks, it resets to 0 and then it starts from task 1, task 2, task 3, task 4. Likewise, it repeats in the loop. So that's what you're going to say in this current underscore task modulo with modulo current task modulus of with maximum tasks. Finish that, save, and do a right click and do a run to see if we got any error at this stage. So build the project. Okay, so far so good. So now we need to write the inline assembly code. This is to initialize the scheduling task. So now is the point you have to write to the stack saying you're going to put that into the scheduling. So you got to write that. So the next step is using the inline attribute. Inline assembly code. This is to initialize the schedule task. To do that, you need to write this prototype attribute naked. Attribute naked, and then void initialize init underscore stack scheduler stack init scheduler task of uint 32 underscore t, and you got to name some name, scheduler top of stack, top of stack. So you got to copy this and declare it outside. So copying that and declaring the function here. Go back to the attribute. Now you can write the initialization for scheduling the task. So first off, to do that, you need to have couple of registers you need to read. So first one, you need ASM volatile MSR register. You need to link that with the MSP, the main stack pointer. Modulus of resetting to 0. So this is a syntax. If you don't know, it is in the reference manual, so please go there and look for yourself. Register R. Okay. Then you need to say where it's linked to, so it's schedule on top of stack. Top of stack, and then you finish that. The next is you need to have the ASM for the dummy, for the coming out of this function. So to do that, it's branding out to bx underscore lr. So bx branding out with the link register. This will return to the function call. Okay, so we return the initialize scheduler task. So now let's save this and run to see if there is any fault, any error. Sorry, getting very thirsty. It's a cold day here. It's about 5 degrees here now. Okay, so that's that. Now to read those two, now we have to initialize the dummy values. Before that, you need to make two variables to read the state and the blocked state. So to do that, you need to go and define these two states above. So go all the way up here and you can declare it here. This is to get tasks ready and block state read. So you got to shift define, come up with the first one, the task ready state, task ready state, which will be 8 bits. So this is for 8 bits, and then the blocked state will be the full state, task underscore blocked state will be the full state. And then you need to create a dummy as well. So we are loading first with the dummy, so you need to define that here. Define dummy program status register x PSR. Need to include the thumb value here, thumb mode. So 3, 4, 5, 6 unsigned. This is for thumb instructions mode. Okay, so now you declared. Now you need to go and create the initialize task stack. Before doing that, let's create void initialize tasks. Task stack of void and then you need to write a program for that, for the function. So come all the way down, you start writing the initialization stack void init task stack of void, and you need to start initializing your stack. So to do that, first step, you need to declare the user tasks. We created 4 tasks, so declare the user tasks of 0. You got to link everything with the state, to the current state, to current state, current state. This is to get the stack to say it's ready to receive push instructions. State. So likewise, you need to copy and replicate for all the 4 tasks that we created. So copy, paste, paste. This will be user task 1, and this will be user task 2, this will be user task 3, and another one. This will be user task 4. So at this state, you need to include in the macro, we got the schedule task, you need to now do an idle task ready, so that you can copy that to the PSP value. To do that, come all the way up here, the define in the stack space, got to copy that, paste it, and you need to create that as the idle stack. Idle stack start. And it will be 9.4, and the schedule task state now will be changed to 5th state. Okay, so you got to copy this, and you need to set with the PSP value in the initialization task scheduler. So the next step is user underscore tasks of 0 with the PSP value now. PSP underscore value, and you just paste it here, idle stack start. And we also need to write a function for idle, so I will start a function with void idle task of void and you need to write a loop. Okay, and you have to declare this task function up here. Go up and declare this idle task. So come back, yeah, you set tasks of 0 into PSP. So now you need to create a function for this idle stack, idle stack start, idle stack start. Okay. So copy this, we need 5 of these. Copy 3, 4, 5. So this will be your user task 1, and the user task 1 will be the stack start T1 state. Stack start T1, stack start. Copy this, come down. The first state is this start here, paste it. And for task 2 it will be T2, this will be T2, and for task 3 this will be T3. This will be T3, and then for the task 4 this will be the T4 stack start. This will be the T4 stack start. T4 stack start, T3 stack start, T2, which is all good. So you copied all the stack, idle stack. Syntax error, user tasks of 0 dot PSP value is idle stack start. So what did we use? Idle init idle stack start. So that's okay, idle stack start. What is a PSP value? PSP underscore value, PSP underscore value, the PSP. For some reason this is not accepting the task 1, task ready state. T2 stack. Now we need to create a link with the task handler. So now user underscore tasks of 0, you need to set the handler now. So task underscore handler to first start with idle task, then you just copy that, and then you need to link with the other tasks. So I'll just copy that, Control C, Control V, task 1, task 2, task 3, task 4. So task 1 will be task 1 underscore handler. So you got to copy task 1 handler, task 1 handler, and for task 2 it is task 2 handler, task 2 2 handler, and for the task 3 it is task 3 handler. Come here and paste it, task 3 handler. Then for the task 4 it will be task 4 handler. Change that to task 4, and we created all of that. So now you need to initialize the dummy data in here in this program. So let's go and create the dummy data. So initialize dummy data. To do that, you need to declare the pointer. Let's go T, the PSP value, pointer PSP, and then just write a far, simple far, and check with the maximum tasks, max tasks, and then increment that. Okay, so we created, so just save and run to this stage. Let's see if there is any problem. I'm sure there is some problem here. I'll fix it. Three errors. So what are those errors? User task of 0, PSP value. Idle size task stack, idle stack start. So coming here, idle stack start, user tasks of 0, user tasks of 0 dot current state, that's okay, dot PSP. Yes, that's supposed to be space now. User task 2, PSP value, user tasks. Okay, I'll give you a short break. Once you come back, I'll fix this problem. So there is some problem happening here, so it's not much to go, and I'll show you when you come back in a couple of minutes. I'll teach you how. So go and enjoy the break. I'll see you in a couple of minutes. See you then.